but this is about serverless. So we'll start off here. So what is serverless? Okay. Just a show of hands, who here is already doing some type of serverless applications? Okay, interesting. So serverless, as you can read here, is about a serverless computing service that runs your code and responds, very important, to events without you managing all those servers, providing automatic scaling, and charging only for the execution time, hopefully. So this new paradigm, if we start analyzing it, if you can see two vertices here, one for code abstraction and another one for how you focus on code logic, things have evolved through time, right? We kind of started with physical machines, move into the virtual machines space as we're traversing these vertices. We reach containers, right, to provide more encapsulation of this business logics. And of course, lambdas are high in these terms of computing evolution. When we talk about this new computing evolution, we've got to discuss about the different execution patterns that are available to you. API-driven patterns, that's going to be one approach for you to interact with lambdas. Event-driven patterns, so you're reacting to events being emitted. Data streaming patterns, and scheduling, okay? There could be more, but these are the ones that I'll be showing to you today. Some of the key points about serverless as we went through our journey here is that for you as a developer, really you got to focus a lot on code abstractions. That's the important part, right? You focus on your code. You don't have to be worrying about other things because the provider will provide you with auto-scaling, fault tolerance, high availability, metrics and logging, which is really important, as we're going to start seeing. No operating system updates, and you pay per use, right? So these are kind of the key points to take away when you're starting to move into serverless architecture. For some project managers, the payment is going to be important, so it's fine that you can show them something like this. There's a free tier in Amazon, for example. You buy executions through 100 millisecond increments. There really is no minimums, no per device fees, no idle fees, which is important. And you actually get 1 million requests free per month. So very interesting approach. The next approach is, okay, how do these functions work? How do we start? Well, first of all, of course, you got to code, right? So you're going to code. I'm going to show you how to code, and then you're going to basically upload that function or that package that you built into the provider, right? Then that provider, you're going to determine how it's going to be triggered, right? Using those execution patterns. And once it executes, well, then you worry about other things once you are in execution mode. But it's a very simple approach. Code, deploy, and test. Like I mentioned, there are different providers. There is AWS Lambda, which I'm going to be showcasing. There's also Google Cloud Functions, Azure Functions. There's projects by IBM, Cloud Functions, and OpenWhisk. But today, we're mostly focusing on Lambdas, even though some of the code that I'll show you at the end and the runtime that we're working on can work for all of these eventually without you doing any code changes, which is the implementations portion. So you have a choice to implement these functions, okay, from the traditional languages, PHP, Node, Ruby, Python, Go, .NET. But today I'm showing you this new language that we've developed called BoxLang. It's a JVM language, so you'll feel right at home. One of the things that we basically grasped when we started working with AWS Lambdas was one topic, which was to focus. I think this was very, very important. It was a little paradigm shift for our minds of how we're going to work with Lambdas now. So we'll always recommend the developers now on our team is, okay, focus on the unit of work. What exactly do you want to do? And that basically starts demystifying that you have to build a big elephant or a big monolith, right? You start building very functional approaches. Thus the word functions. There's several common use cases, from building RESTful applications to data processing, building Amazon Alexa skills that some on our team have built as well, IoT devices, so you can actually grasp information from IoT devices. Schedule tasks, you can actually do scheduled tasks with Lambda and a mixture of other services with AWS. Code execution, that's actually what I'm going to be showing you how we built our serverless application. Of course, now the new rage with AI and chatbots, of course, it's a great candidate for building things in serverless. So I like big pictures, so I'll show you a lot of big pictures. Here's a simple example of real-time processing where you can start with a Lambda that responds to an API gateway. That's also another service in Amazon. So it's responding through an invocation. It's actually looking at other things such as S3. Maybe it's processing a PDF. We're actually using some of this for our Timebox application, which is another service that we have in-house for managing our customers. So there's a request to create a PDF for an invoice. We send the data of it. We generate the PDF, store it, and then we basically send the URL. And that's all it does. Okay? Very simple. You can get a little bit more fancy and start building a little bit more expanded RESTful applications. As long as you put an API gateway on top of it that Amazon offers you, you can create different Lambdas with different functionality. And they can respond to different HTTP methods, different routes, etc. Just like if you're building a monolithic or a normal traditional application that you deploy on a VM or a container. And remember, it's all about the focused approaches. It might not be the most convenient way, but it's possible. Then you can get extremely more fancy and start integrating with a lot of different Amazon services, right? To do things of reactivity, reacting when events happen, when somebody puts a file in an S3, when somebody sends a message on the messaging system. So there's all ways that you can be responding and creating an ecosystem of functions, little functions executing and responding according to the events. Scheduling is another one that you can actually do. So if you actually want to do scheduled tasks based on Lambdas and you are in the Amazon ecoservice, well, you can use EventBridge, which is one of their other services, and you can basically do scheduling of events. And then once those events hit, every day, at midnight, whatever, it'll execute the Lambda patterns that you want, okay? Just like a normal scheduled task. The cool thing about this approach is that, remember, you only pay when this executes. So if it's idle, if it's not doing anything, there's no payments. So once we started learning about all this at Ortus, we had a use case when we started to open source the language, and we really wanted developers to be able to try the language without doing any installations, right? Just right there on the browser. So we developed try.boxlang.io, and this was actually our first production applications, and it's a playground, right? It is built with 2 microservices. One is our mini server runtime, which is a pure Java server that we built, extremely small. It actually runs at about 64 megabytes of RAM. It's very tiny, and it runs the entire application, okay? And then we created the other part of the microservice, which is our Lambdas. So what we wanted is that when you coded, right, and we basically said play, it would send you to our load balancer in AWS, go execute in an available Lambda that we have available, which are very tiny as well, and execute inside of the BoxLang runtime that we defined that is basically snapped inside of the Lambdas, and then give you those results back to you. And then you would see the results of the execution, right? So that was what we wanted to do, and then that's how we ended up building all these runtimes and tools. So if you actually want to play with it, you can go ahead and actually open your phone, try it out. It's try.boxlang.io, and you can start coding. Obviously, there's limitations, right? There's things that you can't do there. But this was our first production application that we launched, and it's been very, very successful for us, especially as a learning tool. And now, after a year of deploying it, we have some cool stats. We actually get about 28,000 executions every day, up and down. Some days are more, some days are less. Some days are 75,000, some days are less. The average execution times of our Lambdas are 38 milliseconds, so it's extremely fast, right? Unless somebody's trying to hack us, right? Then you can see a little bit more, but it automatically kills it. So quick guess. What do you think we pay? And that is estimated to the nearest trillionth. zero. We pay zero, right? We haven't reached that spectrum of 1 million, so we're deploying. We're deploying even more Lambdas, more functionalities, and we're not paying anything, okay? So it's a great deal. So this is what we built. Now I'm going to transition a little bit into best practices, now that I've introduced you to serverless, and then go into the language itself. So some of the things that we learned through this process of a year is here. And there was a guy asking about cold starts and all that stuff. So we have a booth upstairs. So later on, we can talk about it. But one of the important facts is that the code is stateless. Okay, it's just like a RESTful API. There is no state, right? If you want to leverage state, then you can leverage external services, right? You can tap into S3, you can tap into RDS, into Elastic Cache, right? Queuing services, etc. Okay, so if you try to actually put things on disk and expect them to be there, there will not. Okay? You also get ephemeral disk capacity. Okay, so you only get 512 by default, so not a lot. And then you can increase it, but obviously you pay if you increase it, right? So be aware of that. The other one is the max timeout. So this is important. By default, it's 15 minutes. So you want to reduce that if possible, right? For us, since we were doing a coding playground, we didn't want people actually creating a mining facility in BoxLang or something like that. So we reduced it to 5 seconds, right? So if your code executes in less than 5 seconds, if not, it gets killed. Okay? So try to create a timeout for your Lambdas. Concurrent executions as well. I mean, they have a pretty high limit. You can do up to 1,000 at once. Okay? If you need more, you can probably deploy into different instances and then load balance them. So you have that capability if you need more than 1,000 requests immediately. Beware the cold start. I think when you start working with it, you think it's all great, and you look at it and you treat it as a normal, let's say, Java developer, and you end up basically waiting for things to start up until you learn, obviously, about cold starts and how you can improve it. So a lot of improvements is to use static constructs to avoid recreations. The actual class loaders inside of Lambda will actually respect that. So if you put a lot of things into that static construct, they will be respected across. They also have a cold start button that you actually pay a little bit if you want to activate it, which will take a snapshot of that instance that you're creating on. And that's how actually we were able to get into sub-milliseconds to be able to start up our Lambdas. We also do pre-compilation of a lot of things. So everything is pre-compiled and serialized and then unserialized at the startup. So there are techniques that you can do to get really, really good performance. And we're very happy with the performance right now. Payload size here is really, really important because it's also BIDAS. If you're trying to do a post to a Lambda of an image, and let's say that image is bigger than 10 megabytes, it will not work, right? So you get basically 6 megabytes synchronous, and the responses are also limited. So functions are not good if you're going to be transmitting large amounts of data, okay? So use them at that discretion. Logging and metrics, this is important to know what's happening inside of the cloud. So use it. It's really included, okay? Like you saw, we pay nothing, and we've activated every single logging knob there is, right? We encourage you to enable these two. This will give you even deeper metrics into your executions, okay, and what's going on inside of every type of execution. So there's really a wealth of debugging data there available. Sometimes not easy to query, like sometimes anything with AWS. But once you get into it and learn it, then it's a lot of wealth of information. So use it. The next one, BIDAS as well, which was deployment limits. Right? So very tiny spaces in their docs, they tell you these limits, which is 50 megabytes. That's a zip or a jar. That's it. Anything more is not accepted. Okay? And 250 megabytes unzipped. So if you upload a 50 megabyte zip file, but it unpacks to 300 megabytes, it will not work. Okay? You can have up to 5 layers of dependencies when you're working with Java. We actually found a way to not even use 1 layer. I'll show you a little bit about that as well, especially by using a fat jar. Okay? Use container images. So if your Lambdas are getting bigger or there's a reason why they're bigger, well, consider using a container image because then you can go all the way to 10 gigabytes. Okay? Plus, you can take advantage of the startup of the container, so you can warm up your Docker images. So we're actually considering to see how the performance is going to be with containers. So we're actually building try BoxLang as a container and seeing how it behaves. And I'll be showing you our template that we built to basically hopefully make it really, really easy to get started, to package, and to deploy. But remember, focused work units is what you want, right? You don't want to be creating full-blown applications here. You want to focus. And the other one that bit us a lot was power levels. We really had no idea at the beginning, okay? There is no knob for you to control the CPU. It's only memory. So the more memory that you give your application, the more CPU you get. Again, it's very hidden in the docs, but once you find it, you will see a world of a difference in terms of performance. We started with the default at 128, and it was dog slow. We found a sweet spot around the 4 GB mark. So around the 4 GB mark, you will see really, really good performance and really good CPU. Another tactic per se is that ARM processors, for a reason, using Java are faster than x86 in our testing. Plus, they're cheaper. So if you're actually paying for any of those serverless, if you use ARM, when you define your function, you will actually pay, I think it's 10 cents or 20 cents cheaper. Okay. Now, if you really are a geek and you want to save money because you have a lot of functionality, then you can use this project. It's called AWS Lambda Power Tuning. You can finely tune the exact power and the exact amount of things that you will want on your Lambdas. We haven't even gone there, but it's really a more involved process for you to do tuning. Another tidbit here is to use SAM. This is built by AWS. It's basically a fancy word for infrastructure as code. You can install it into your operating system as a CLI tool. And it's great because it allows you to basically do local testing of your Lambdas, just like if it's being deployed. So you can create a JSON script. You can define how you want it. For the inputs, you can create a YAML file, which has all the different events that are going to be executing, and just use it locally. So really, really recommend it for you. When I started, this was a lifesaver in order for me to not do the deploy, wait for the deploy, test, and figure out that I broke something. Okay. All right, this is the end of part 1. Any questions for part 1? No? All right, good. All right, we'll move to part 2 then. Okay, so BoxLang. So what is BoxLang? Well, BoxLang is a new modular dynamic language for the JVM. We're aiming for productivity. That's kind of our ethos, is to be very expressive, very functional, and available everywhere. We really designed the language to its times, especially the day that we live in today. It is dynamically typed, so it is not statically typed. Types are optional. There is a lot of type inference, a lot of type coercion at runtime, but you can also use static typing, pseudo-static typing if you wanted to. It supports classes. It supports also scripting, which is important, and it has also a built-in templating language as well. Like I mentioned before, we were creating frameworks and libraries for more than 20 years before we open sourced our language. It includes modern Java interop using all the latest JDK features, including invoke dynamic. So we built a framework for dynamic objects inside of BoxLang. Highly functional. We do a lot of things based on functions, okay? From context-aware closures to lambdas. Like I said, built-in framework. I'll show you a little bit of the concerns, not everything. And our big focus was to be small, lightweight, and modular. We really wanted to run at the chip level. So we actually designed this to be able to work on embedded systems and IoT devices first, and then move out into the different runtimes using our modular capabilities. We decided to open source this. This has been in development for us for more than 2 years, but we open sourced it last summer in the US. We've done about 27 releases every month. Every week, actually, we do a new release, and every month we'll do a big minor release. And we're targeted for a release candidate this month and a final release at our developer conference in Washington, D.C. This summer, this May, and you can check it out. Some people have asked us in the booth, why did we create this? And it wasn't because we woke up one day and said, hey, I want to build a language. We're a little crazy, but not that crazy. But you can find out here. Okay, we wrote up a big engineering blog of why we made the decision to build it. So I'll take you through a little bit of the features and then arriving at the Lambda runtime and the Lambda templates. This was very important for us in the day and age that we live. I think Kotlin really made this intricate for Java, basically, is to be able to run in multiple runtimes. So it has that same approach that we run on different runtimes. We've created all of these runtimes. Some you can create because it's just a simple jar. So from Docker native to our own Java mini server, we have our own servlet implementation as well that we launched more than 15 years ago called Command Box. Any servlet implementation, the Lambdas, we're working on Azure and Cloud Functions as well. Android and WebAssembly are coming, and there's actually a VS Code one that we launched as well. So the entire language, you can basically extend VS Code with BoxLang. And if we have time, I can show you some of that. Another important aspect is that we dealt with a lot of legacy systems, and we really wanted to make sure that we could bring all those legacy systems back. So the parser has been actually implemented as a multi-parser architecture. We've made a lot of emphasis on what we call the BLAST, which is the BoxLang aspect, abstract syntax tree, which is to convert your code into this encapsulated and agnostic AST tree. And then we can basically take different languages and transpile them, and they work in BoxLang. So we've actually worked on a few transpilers for it, and some in progress. But the idea is for us to be able to bring the old into the new. So how does it look like? Well, we can look at some semantics. So you get three types of files that you can interact with. You have a BX, which is a class, BXS, which are scripts. So you can do just pure scripting at the operating system level. BXM, if you're building UI applications in the web, for example, or mobile, you can actually have a full templating language available to you. Some differences. We act on the concept of scopes. So when you create variables, depending on the context of where you create them, they are backed by different things, right? Different situations. So for example, when you define a function without any type, obviously we'll infer it from its value, but they're backed by concurrent maps. And if you're building scripts, they have available a variable scope. If you are functions, then you have argument scope, you have local scopes, and anything surrounding that function is available to you. If you're building classes, well, you have a traditional, like in Java, this and variables, but you also have the static scopes. And another interesting aspect of it is persistence. And we actually give you also different global scopes that are available depending on the runtime that you're on that gives you lifespan. So if you want a singleton, well, just put the object in application scope, and it'll survive the entire application. If you're in a server, just put it into the server scope. If you're in a web server and you have a J2E sessions, well, you can use the session scope. So we've tried to basically give you that functionality of scoping and persistence very, very easily. Okay. As you can see, you can define when arguments are. We'll go a little bit about them. Traditional var scoping like they introduced in the JDK. You can actually completely grab a scope and interact with it. And you can see all the different variables that are available inside of that scope at once. You can even do filterings. You can do any type of functional aspects on those scopes. Okay? And then, of course, in the classes, you have the different available approaches, which are very similar to Java. We also have a lot of enhanced types, because obviously we're working in dynamic land. It's no longer just static. Member functions are a big deal. We want to make everything as functional as possible. Okay? So you have access to everything that you're used to in Java, plus different things such as structs. Basically, structs are maps that are case insensitive. Okay? They're case insensitive, and you can have different types of maps, just like in Java: ordered, unordered, weak, soft, etc. We have a native query object, especially dealing with JDBC. So we abstract all the JDBC intricacies into a very nice JDBC framework. Datetime objects, so you can actually interact and produce actual JSON ISO specific types with it. Numerics, so we have the concept of numerical types that could be subtypes of float, of short, of int, of double, big decimal, but it's all abstracted for you. right? So if you want to do big decimal mathematics, you don't have to use all the big decimal functions. It's already automatically calculated for you, depending on the results it changes. As you can see here, for example, you have traditional member methods, normal. You have ways to grab a string, convert it to an array, filter it, iterate over it, introduction of lambdas on it. It's all auto-castable. So as you pass these functions around, and you move an int where a long is expected to be, it will automatically coerce it for you, and vice versa. So there's a lot of these things to help you be dynamic and functional. And of course, to be fluent as well, you can return functions that are first-class citizen. So just like when it was introduced in Java for the lambdas, they can be moved around. You can create basically a map with different lambdas and treat it as an object. So you have a lot of capabilities here. Especially defining functions, you have a lot of other capabilities. This would be similar if you're using something like Kotlin, for example. You don't have the verbosities, right? You can have a completely typeless function with typeless arguments doing some type of mathematical computation. You don't even know what it is, but it will automatically do it depending on its values at runtime. You can do optional generic types, okay? Or you can do very specific types. It's really up to you, right? Depending on the mood, I guess. All the functions are public by default. All the functions return anything by default, right? And all arguments are, of course, any by default. And then you can determine and pinpoint exactly as you need, right? There's also two types of inference. So we're going to be able to infer and do compilation time optimizations, but there will also be runtime optimizations as you start running your application as well. Like I said, it does all the auto casting for you. In all reality, there's no need to cast. There's type promotions and type coercions. And we've tried to make it really easy for you to be able to work and interact with different Java libraries, of course. Arguments, of course, you get all the same functionality, for example, of what a Kotlin offers. We've had this for a long time, which is non-required arguments, default values, but we also have argument binding, and this is a huge help. Oops, passed too far on that one. Go back. There you go. So you have argument binding. So remember, we're talking that scopes can be actual maps. So you can actually build your own little map. And basically, when you call a method, you can say, hey, method, I want you to bind the argument collection to my map. So that could basically send everything inside your map into the function. And even if there's extra arguments that don't match to the specific argument interface, it'll still pass them through, and then you will have them available. So there's a lot of flexibility if you want. And that's the difference of a dynamic language, right? You also have productivity hacks, such as the null coalescence operator or the Elvis operator. You also have safe navigation, so you can navigate not only anything that's dereferenceable can be navigated safely. So that means that arrays, queries, XML objects, methods like here can all be safe dereferenced. And you can use in combination to the Elvis operator and say the email is going to be inside of this user. If they have that get email function, it'll execute it or it'll assign it a variable from the Elvis operator. So we try to focus a lot on productivity hacks in that sense. String interpolation was also a big one. We wanted to make it extremely easy that we used to. So really, even if you do string concatenations, they will be actually using string builders behind the scenes. So you don't even have to worry about string builders anymore. We even calculate that. Anything between hashes is also expressions. So we've done a lot of UI work at Ortus as well, and we brought a lot of cool UI techniques into the language itself. So anything you put inside of those hashes, like in Vue.js, for example, it's an expression. And that could be fully whatever you want. Okay. You also have big strings. So there is no difference of using the 3 quotes in Java, for example, for a big string without line breaks. For us, it doesn't really matter. So just use 1 quote, and that's a big string, or it can be a small string. It doesn't matter. You can combine them as well with scopes, like I mentioned, right? So you can do buildings of templates or anything of this nature. So string interpolation makes it really easy for building UI applications as well. Closures and lambdas, of course. Functional programming was integral to any language nowadays. You have the same things available as in Java, the context-aware closures, but you also have pure functions. We introduced the concept of a pure Lambda, which basically allows you to have no context. So that means that it's very deterministic. The arguments that come in are then the value that comes out. Okay? So there is no mutations in that sense, and allows you to build pure functions, which are extremely fast, so you don't have to do lambdas if you don't need to as well. You can actually move them around. They're first-class citizens, so you can pass them. There's actually an argument type called function. So you can receive a function. You can actually return a function, right? That's also a type. It's a native type. Okay? And of course, we also do automatic coercion. Since we're in Java world, if I'm using here, for example, a completable future, I can just say run a sync. Here's a lambda, calls another function. There's a then and another then, moving with closures now instead of a traditional lambda. So we'll do the automatic coercing from the specific Java lambda that is expecting to the BoxLang closure or lambda. So this is seamless for you as a developer. Classes will look just like your traditional classes, except very, very less verbose. We have the concept of properties for your fields. Okay? There's automatic constructors available to you. There's also automatic toStrings, equals, and hash codes, just like in Kotlin that you receive, or Groovy. Automatic getters and setters are available to you as well. You can turn them off if you wanted them as well. Annotations are available to you, just like in Java as well. But you don't even have to define those annotations. Those annotations are dynamically created for you. So you don't have to create a class for that annotation if you don't want to. JSON is also first class. So anything, even Java types can be converted to JSON automatically. We have a JSON BIF called JSON serialize and JSON deserialize, but even objects have member methods called toJSON. And it will look at the properties and it will try to give you those properties converted into JSON. It'll do deep integrations, deep hierarchical introspections. You can actually say which ones are going to be marshaled into JSON or not. So you have pinpoint control to bring that state out of an object using JSON without you doing extra hoops. Metaprogramming was a big one. I was a Groovy developer at one point in my life. Loved Groovy. A lot of those concepts were introduced into BoxLang as well. This is available on any object, even Java. So Java objects actually can be mutated at runtime. We have a special class, a special object called on every class $bx, and that is available into metaprogramming world. Okay? And this gives you access to the metadata. So if you did runtime annotations, they will be available there. Static annotations will be there. Documentation will be there. The class representation is there. And then you have a lot of things that you can change at runtime. So you can actually do change listeners. So imagine you can grab a map, okay, or a scope, and you say, hey, I want to register a new listener, okay, with a closure, and you're going to receive the key that was trying to be mutated, the new value and the old value. Part of the language. So a lot of event-driven mechanisms are available to you here. Okay? So you can inject properties using that metadata. You can remove properties. You can inject methods. You can remove methods. You can mutate methods. So there's a lot of dynamic aspects that you can have at runtime. Then the templating language. If you're building UI applications, we've really taken the best of everything that we've used, from JSP to Blade to Groovy server pages to CFML, and kind of created a language where you can actually very easily create templating and extend it. As we'll see, the modular capabilities of the language allow you to actually generate your own tags into the language, and you can basically just go and do your business. Right, so this was a little bit of the semantics just to introduce you of the differences. We're going to be using a lot of the BoxLang framework capabilities for the Lambdas today. So the BoxLang framework is composed by these major services using service patterns. The first one is our application service, and we use this in the Lambdas because it allows you to create virtual applications depending on packages on disk. So in the good old days, you had web contexts, for example. Well, that kind of simulates that and creates different applications that you can have at runtime. We have a lot of emphasis in BoxLang with asynchronous computations and parallel computations. Everything from the JDK is exposed into our framework, and the synchronous services allows you to register your own executors, work with virtual threads. Anything that you're doing asynchronous is available to you. We've also done lots of caching frameworks in the past. We've migrated them to BoxLang, and you have a full enterprise caching engine available to you with different providers that you can connect to other caches. So it becomes also a cache API that you can be working with any cache at any point in time and have the same API. Component services, we saw the templating language. Well, the component service allows you to build and extend the language with your own tags if you wanted to, or if you're doing just kind of scripting with your own components in script. So this gives you, the developer, a basically ability to extend the language your way. A lot of emphasis, of course, on JDBC. So we have a full integration with database services, JDBC connectors. We've built all the modules for all the major vendors, so you can easily integrate with one line of code. You can query the database. Functions as well. We have the concept of global functions available to you. So you can also basically generate your own global functions and available anywhere, scripting, classes, etc. This is one of the most important ones. We'll have another slide on this one, but it's the event-driven aspects of the language itself and the modularity. I'll go through them a little bit later. And scheduling. So scheduling, we don't use in Lambda because there's already AWS Event Bridge, but if you wanted to do an operating system cron job, the language already has scheduling service and schedule tasks built in. The modules is the interesting one. This is what has allowed us to build all these different runtimes. And this allows you basically to create different functionality that the language can basically adapt, and you can contribute things to the language, and you can also extend the language, right? We give you a framework of hierarchical class loaders. It is not OSGI. It's something that we built actually almost 15 years ago for our native framework called CodeBox. And then we ported it over here. You can build them in Java, you can build them in BoxLang, or you can build them in both. You can be combining them. And we have tons of examples. We have over 40, 50 modules now that you can learn from. We even have a module template to get you up and started. We have a lot of emphasis on the CLI, so you can actually build modules to interact with CLI packages. And of course, it integrates with all the tools you're used to, Maven, Gradle, etc. Just mention a few modules that are available to you. FTP frameworks to work with FTP and STP sites, email sending capabilities, ISAPI integration, UI forms, password encryption, all the JDBC libraries. We did a lot with image manipulation, so pretty much anything you want to do with an image, you can with that module. PDF tooling as well, from generation to PDF form binding, CSV and spreadsheets, INI files. There's Brad with a crazy hat that's built on a Raspberry Pi upstairs. Oh, he's here. All that is built using Oshi as well in the Pi4j library. So you have all YAML support, etc. So our idea is to be able to have a nice ecosystem for the language as you build it. The application framework that I was mentioning today is how we built the Lambdas. In our case, we don't have sub-applications. We just have one application in the virtual root of the function. But this allows us to basically control the different aspects of the language. But if you're deploying or building web applications, you can basically segregate them into sub-applications very easily and create different memory spaces all in the same BoxLang runtime. The important thing here is the life cycles. So you can listen when your application starts, when a session starts, when a request starts, when there's an error. So there's all these events that are being emitted in order to make your life easy. And I keep talking about events and events and events because the reality is that without event-driven language, none of this would be possible. So the idea for you to have observers native at the actual language is super, not only important, but it allows you to basically grow and make the language as you see fit, because anything can be interceptable. Okay? So you can create different interceptors. As you can see, it's very easy. Okay? And then you can actually create different functions to listen to those events. And then you can extend the language as you see fit. And you can create your own events. So this means that if you have an application that you're building, a CRM, for example, and you want to create your own events, well, you can. And it's already a matter of defining them and exposing them. All right, so all that basically culminates on this runtime. So when we tackled that problem that we wanted code execution, and we started with the BoxLang runtime, of course, we had to go through all of what AWS offers you. And we leverage, of course, the Java SDK. They show you how to implement the Java handler and execute. So we did that. So you have this right here, and it's all documented, of course. One method to integrate into BoxLang. This will bootstrap the runtime, your configurations, your modules, the dependencies, even Java dependencies, right? And it'll all build it for you. It's tuned for fast startups with all the lessons that we learned, okay? And it really acts as a front controller. So it receives the request of Lambda, and it will inspect the incoming request. It will convert it from JSON into a struct, right, or a case-insensitive map available to you. It'll do automatic logging and tracing, so you're going to even be able to determine what's going on. Automatic error handling, so if there's exceptions in your entire Lambda, it will take care of making sure that they're logged, that everything is received and returned. Okay? And it will delegate to the appropriate class and function all by convention. Especially since we've been doing all that framework work, we wanted to bring a little bit of that. Right? And of course, automatic response handling. Since we're building Lambdas and they adhere to RESTful capabilities, we want to make sure that the return or the response was cohesive. And it was the same for everything. So if you look at the big pictures that we love, we have a Lambda request that comes into a Lambda runner. The Lambda runner is in charge of making sure the runtime is up and loaded with all your dependencies, modules, and configs. And it executes your class by convention called lambda.bx with a specific run method. Okay. So how does this look like? Well, you, the developer, implement this class. Okay. By convention, it's called lambda.bx. If you do the template, it's already there with one method called run. You get 3 arguments. We'll go discover what those arguments are. And you can have that optional application.bx that we were talking about. So you can make it basically adhere to more framework features. Okay? And then you can even expose more of these functions via a header. So if you pass a header into that RESTful function that has been exposed, then you can even target specific methods on that class. Okay? So that gives you a little bit more flexibility as well. And we're also introducing this into our next release candidate next week, which is exposing more of these lambda.bx's by convention by looking at the incoming route. So if there's a route coming in called customers, it will look for a customers.bx. And it will execute by convention the run method. So starting to get a little bit more activity in building the lambdas. So how does the code look like? Well, here's an example one. It's one function called run. It receives the 3 arguments. As you can see, there's no types. You can type them if you want. The first one is a map of the request, which is a struct, so case-insensitive object containing the entire request. And you can do it, safe navigation on it. Everything's available to you. You can print it. We even have a function called dump that it will dump it to the console deeply with all the values inside of it. You have a context, and this is an important one. The context object that you receive will be based on the cloud provider that you're using. So right now, this will be an AWS context. But if we move to Google Cloud, or if we move to Azure, this will be the different context for those services. But your code remains the same because it's dynamic. It will adapt depending on which cloud provider you are on. And then, of course, we even give you a response map as well, and you can use it if you want. Okay? You have the option to return either nothing, right, which is just an acknowledgement that it actually worked. We'll do the status code of 200 for you. You can do a simple value, so you can just return a string or something, or you can even return a complex value. And we will take that value, serialize it to JSON, and always return the response according to the provider that was requested. So that was really important for us, is to have the capability to move to providers without changing our code. Now, everything that we've learned basically through the whole year of working with this, we kind of put together into a template. And the template is there, it's open source, it's available for you to use. It's really just a turnkey template for Lambda development. We're huge into testing. Obviously, we've built a lot of testing frameworks. So unit and integration testing is available already on the template. With JUnit, our own framework test box. It has SAM integration as well. We've actually built the JSON files for you in the YAML. It has Gradle integration right now for your Java dependencies, for packaging, and actually testing this as well. We're not big into Maven, so if somebody wants to do a pull request for Maven, more than welcome. And of course, we have our own package manager for BoxLang, which is called Command Box. So if you need BoxLang modules, you have those dependencies as well. And then we even give you the GitHub actions for automatic testing, automatic packaging, automatic deployment to AWS. And as we start building more of the providers, all that automation will be available to you as well. The end result will be something like this. It will be your package Lambda according to the vendor that you're deploying it to, with your lambda.bx, with the optional application.bx available, with a custom boxlang.json. Basically, the entire language can be configured with a JSON file. And this is something really that we wanted to introduce as well, specifically because we wanted, Jorge's machine to be the same as my machine in terms of language implementation. So we've abstracted the majority of what a language runtime can be configured with into a specific JSON file. We have the lib folder, which includes the runtime and any Java dependencies that you require for your Lambda. We'll take care of all the shadow jar for you and package it. And of course, if you're using any of our modules, they will be separate as well. So all that is basically available to you with just running Gradle build, and that's it. And then you focus on coding. So with that, hopefully you'll get an insight into serverless, an insight into a new JVM language, and how to build these serverless applications. Go try it, please. You'll see it's rather easy. I'll show you the full documentation as well on it. So let me show you. And we can move to questions. And if you see some of these guys, they're upstairs in the booth as well. And let me put where you can find all these docs. Mirror. There you go. So BoxLang.io is our website. Try.boxlang.io is where you can, the one that we built. And boxlang.ortusbooks is all the documentation. Everything's fully documented with the language. And if you go to Lambdas, everything's here on how to take you step by step and start building these serverless applications. So I know we have like 10 minutes? 8 minutes? 5 minutes?
A few minutes for questions here, and then they can take them afterwards.
Okay. I don't know if you guys have any questions, concerns, comments, jokes, riddles.
IDE support?
IDE support. We have actually our own IDE based on VS Code. So yeah, it has a line debugger. It has introspection into it. It actually has the runtime that I was telling you about. It runs inside of VS Code. And we're actually working on the testing patterns to integrate with our own testing framework embedded into VS Code. So we've done a lot with VS Code. I don't know if I have it here. Maybe I'll show it to you. So actually, here's the template. So, yeah, it looks horrible. But you'll see that here is the BoxLang portions, and you can even define servers here and the different BoxLang homes. There's the language server that it connected, right? And then you can interact. So we're talking about the Lambda here. So if we look at source, main, Lambda, this is how a Lambda looks like. And you can do the traditional breakpoints and execute your Lambda and all that stuff, introspection. And it's a dynamic language, so things might not be what it are until runtime, but there are hints that we're going to be adding as well into it. Even compiler hints as well to make things faster. But yeah, we're doing a lot for tooling as well. Good question. Yes?
If I want to start like Lambda function with BoxLang, do I need to use a template like Chrome?
Yeah, that's the easiest, right? So if you actually go to the template, GitHub, I even forgot it. Go to BoxLang and you look for the template right here. We even added a button for you, so you can say use this template right here on the top, and you can create a new repository. And I'm going to be adding actually code space support next, so you can even code on the web. But yeah, you can start like that very easily, download it. Make sure you have JDK 21, right? And I think the IDE even now prompts you now. So we added support into the IDE, into our extension, that'll say, hey, you don't have the right JDK. That's the easiest. Yes, so good question. So if you go here into the CLI, right, and you just type, oops, stuck. It's stuck. All right, it's stuck. But if you type BoxLang, it's a CLI. So we've done a lot of work. We started at the CLI first. So it has even different BIFs for reading input. It already parses all the arguments into positional, named. It gives you all that available out of the box to work with CLI.
Right. Thank you very much.
Thank you. Appreciate it.